Hello viewers, in this video we'll be solving this exciting problem. Find the domain and the range of f of x equals to 3 over root x minus 2. So let's start with the domain. To find the domain here, we have an even root, so we need x to be greater or equals to 0. And we don't want the denominator, we don't want it to be equals to 0. So this means that root of x cannot be equals to 2, which means that x cannot be equals to 4 as we square both sides. So, but here, so we have these two conditions, this and this one. So let's put them together. So if you have your number line, this is 0. X greater than equals to 0 is this one, right? But we have that x cannot be equals to 4. So here is 4. So its 4 has to be open. So we have to open at 4. So that's it. So it means the domain is nothing but from 0 close, 4 open, union, 4 to infinity. So this is the domain. Now let's find the range. Okay. Now to find the range of this, we have to consider what the domain is, right? So we can start with this. We have two parts of the domain. So we're going to consider the first part and the second part of the domain. And I'll tell you why. Now, what do we know? We know that what? Root of x is what? Is always greater or equals to 0. Right? Okay. So it means that what? It means here we're trying to create this y. So we can subtract 2 from both sides. So root x minus 2 is going to be greater than what? Equals to minus 2. So what is my goal? I'm trying to create this one. But at this point, look at something. You know, root x minus 2 is in the denominator. So we need to find a way to get this to the denominator. So one thing we can do, we can think of doing, is to flip this, right? So that we flip it to be minus 1 over 2. But this is not always correct. The reason is because we don't know what is root x minus what? Minus 2. Is it always negative or is always positive? So let me explain something briefly. What do we know? If you have a is greater than b, for example, let's say 2 is greater than 1. Let me use 3 here. 3 is greater than 2. So we can say that 1 over 3 is less than 1 over 2. This is true because both of them are positive. Now, if we have this also, minus 3 minus 2 is greater than what? Than minus 3. So we can say that what? Minus 1 over 2 is less than minus 1 over 3. This is true. Why? This is true because both numbers here are positive and both numbers here are what? Negative. But in a situation where we have this one, for example, we know that what? We know that 3 is greater than what? Minus 2. This is also true. But can we say that 1 over 3 is now less than minus 1 over 2? No, this is not true. You see, why is it not true? Is because these two numbers, they are not the same sign. This is positive, this is what? Negative. So when you flip and you flip the inequality, You are not sure if this, so this is, yeah, in this particular case, is not true. Okay, so we have to be careful before we flip. Now, in order to flip this, we need to be sure that this number is also what? Negative. Because if this number is not negative, let's assume this number is positive, and which it means, and this number can be positive, right? This number can be positive in which domain? For example, if you take x from here, if you take x to be 16, 16 is in this domain. So root of 16 will give you 4, will give you was 4, right? And you see 4 minus 2 would give us 2. So this will be 2 greater equals to this one. So if we flip this, this will become 1 over 2. And you flip this, less than minus 1. You see that this statement is not true. So it means we have to avoid a situation where we will have this to be positive, where this will be positive. So we have to avoid that situation. Because if this is positive and this is negative, by the time you flip it, the inequality will not be true. So one way we can do that is restriction. So I'll show you what to do. So I hope all of this is correct now. So let's do away with this here. So, but if we look, if we take any x, let's restrict our x first. If you restrict your x to here, so let's take this one. Let's say we have our x is coming from only 0 and 4. If you take x is coming from 0 and 4, you see that root of x is always greater than 0. This is true. And for any x you have here, the root of x minus 2 is going to be what? It's going to be like, it's going to be a negative number. For example, take 2. If you take 2 here, you will have square root of 2. Square root of 2 minus 2 is going to be negative, right? So it means this number is negative and this is also negative. For example, take 1. If you take 1, which is also in this domain, you will see that root of 1 is 1. 1 minus 2 will be minus 1. So it means for any x you pick inside this domain, this number is always what? Negative. So because of that, you have a negative number greater than equals to a negative number. We can now flip. So this will hold. So this will be less than equals to 1 minus half. But don't forget, we have restricted our value of x now to this. So here we can multiply both sides by 3. So this becomes 3 less than equals to minus 3 over what? Over 2. And what is the whole of this one? This is our y. So we say that y is less than equals to minus 3 over 2. So which will be from minus infinity to 3 over 2 close, right? Minus 3 over 2 close. So are we finished? No. Why did I say no? Because this solution here, this method, we only restricted our x to be coming from where? 0 and 4. But our x can come from where? 4 to infinity. So let's do that part now. So let's say now our domain is where? 4 to infinity. So let's do the same method. What we're trying to do now is this. We're trying to find still the second part of the range, which is going to be, we know that the root of x is always greater or equals to 0. This is true. But in this case, since our x is coming from here, our x is coming from 4 to infinity, it means we don't need to use, and don't forget this 4 to infinity is open. So here you can see the 4 is open. So here is also going to be open, right? So here we don't need to use 0 because we don't even have 0 in this interval. So when you say root of x is greater than 0, it's true, but do we need 0? No, because there is no 0 here. So we can remove this and just start with the fact that what? The root of x is always going to be greater than what? You know, the smallest value here is 4, so the root is going to be 2. So the root of x is always greater than 2 in this case. Now with this, information, you can try to create what is y. So let's subtract 2 from both sides. So you have root of x minus 2. This will be greater than 0. Now that you have this to be greater than 0, then we can flip easily. Why can we flip? If you have, for example, a number 5 greater than 0, 1 over 5 surely is still greater than what? 0. And we are sure that the number here is always greater than 0. Because what will make this number 0 is what? Is when x is 4. Because if x is 4, you will have root of 2 minus 2. But 4 is not in the domain because this domain is open here. So, for example, take any x in this domain again. Let's take x here. Let's say which is, let's take a big number. Let's say we take 12. Root of 12 definitely is bigger than 2. So, root of 12 minus 2 is still going to be positive. So here we can flip this to be root of x minus 2. The inequality will still remain. This is still greater than 0. Just like I said, anytime you have a number greater than 0, if you flip that number, the inequality is not going to change. It's still greater than 0. So now I can multiply both sides by 3. So this will become 3 root of x minus 2, which is still greater than what? Than 0, right? So what have we created like this? This is our y. So y is what? Is greater than 0. So which means you have what? We have 0 to where? To infinity. So in order to finish now, we have to find the range. So our range is going to be this one. We got this first part. So you have minus infinity to minus 3 over 2 close union this second part, which is what? 0 to infinity. So this is the range of this function. So here we did two things. We have to separate, we have to consider when x is coming from here and when x is coming from 4, 8. So that is how the domain is very, very important. Before you can even find a range, you need to look for the domain because that will guide in how you choose your values. Okay, I hope this video is clear. Thank you for watching.